All right, this is Chapter 1, Lesson 4, the coordinate graph and the coordinate graphing system. So we're going to take a look at the coordinate graph and then label a couple of things on the graph so that you know what we're talking about as we go through. So at the top I have the blank corresponds to a number on the x-axis. In that blank you're going to write x coordinate. And then the one pointing to 2 is the y-coordinate. So the x-coordinate corresponds to the number of the x-axis, and the y-coordinate corresponds to a number on the y-axis. All right, and these three blanks over here, you're going to put y-axis, origin, and x-axis. So the y-axis is this vertical line that goes up and down. The x-axis is the one that goes horizontally straight across. And the origin is this point right here, 0, 0, center. On this side, you're going to put x-coordinate, ordered pair, and y-coordinate. So the x-coordinate refers to 1, the y-coordinate refers to 2, and the ordered pair is both of them together, 1, 2. Maps have grids to locate cities. The blank blank is a type of grid that is formed when two number lines intersect at their 0 point. The number lines separate the coordinate plane into 4 regions called blank. In those blanks, you're going to write coordinate grid. And quadrant. So the coordinate grid is a type of grid that is formed when two number lines intersect at their 0 points. The number lines separate the coordinate plane into 4 regions called quadrants. And blank blank is a pair of numbers such as 1, 2 used to locate or graph points on the coordinate plane. In those two blanks, you're going to write ordered pair. So an ordered pair is a pair of numbers such as 1, 2 used to locate or graph points on the coordinate plane. All right, when you're graphing ordered pairs on the coordinate plane, to graph an ordered pair, I draw a dot at the point that corresponds to the coordinates. So, for example, if I have 4, 5, I would go over 4 on the x-axis and up to 5 on the y-axis. Okay? You can do the same for any of these. -3 tells me to go towards the left-hand side, okay, which would put me in quadrant 2. 2 negatives will put me in quadrant 3, and 4 and positive and a negative will put me in quadrant 4. So for 6, -2, I went over 6 and down -2. For -5, -5, I went over -5 and down -5. Okay. So the x always tells you to go left or right, and the y tells you to go up or down. Okay? If you're going to the left side, it's usually a negative. If you're going to the right, it's positive. If you're going up, it's positive. If you're going down, it's negative. So in order to graph reflections on the coordinate plane, you can graph points that are reflected across the x and y axes. Remember that points reflected across the x-axis will have the same x-coordinate and their y-coordinate will be opposite. Points reflected across the y-axis will have the same y-coordinates and their x-coordinates will be opposites. Okay? So if we look at this, if your x is 0, it doesn't move. If it's positive, you move right. If it's negative, you move left. If your y is 0, it doesn't move. And then it moves up if it's positive and down if it's negative. All right, so we have a reflection across the x-axis. The x values stay the same and the y values change signs. When you go across the y-axis, the y values stay the same and the x values change signs. So taking a look at an example, graph A to -4, then graph its reflection across the x-axis. So we went over 2, up 4. Sorry, we went over 2, down to -4, which is the point A. And then A prime, or A with that little apostrophe, that's what it means, A prime. Okay? So I went over 2 and up 4 this time because it was graphed across the x-axis, reflected across. Okay? For letter B, graph B, -1.5, 3, then graph its reflection across the y-axis. So -1.5 is halfway between -1 and -2, and I went up 3. Well, I had to graph it across the y-axis, which is B prime. So instead of going left -1.5, I went right 1.5 and up 3 to get B prime. All right, so there are a couple of try problems out below. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, this is what your picture should look like when you're done. As you can see, I used some different colors for different lines. There were 4 different lines that you needed to connect. So, and that's the shape that you should have at the end of this. All right, now that you've had a chance to try out the try problems, let's go over the answers together. So, for number A and B, you actually can just cross those off. You don't have to do them. Okay? Letter C says, name the ordered pair that is a reflection of the point 1, -4 across the x-axis. So, remember that when you're crossing the x-axis, the x-coordinate stays the same and the y-coordinate flips. So, my x stays the same, my y becomes positive. For letter D, name the ordered pair that is a reflection on the point -2, 5 across the x-axis. Again, the x stays the same, the y becomes negative. And you're just moving it from up to down or down to up. Okay? For letter E, name the ordered pair that is a reflection of the point -3, -1 across the x-axis. Okay? So again, x-axis, -3 stays the same, my y becomes positive. And for letter F, name the ordered pair that is a reflection of the point -3, -1 across the x-axis. So again, -3 stays the same and 1 becomes positive. All right, for the last 3, I have name the ordered pair that is a reflection of the point 1, -4 across the y-axis. So this time my x-axis stays the same and my y flips, so my y becomes negative. For H, name the ordered pair that is a reflection of the point -2, 5 across the y-axis. Again, my y stays the same. My x, which was -2, flips to become +2. For I, Kendall placed a fence post at -4, -4. What is the location of the post that reflects -4, -4 across the y-axis? So again, -4 and my y value stays the same, but it flips in my x value, so it's 4, -4. For letter, I have this graph here, okay, and it will help me with the 9 problems that I have. So, for letter A, it says graph the point A across the x-axis and then state the coordinate point. So, it actually wants me to graph the reflection across the x-axis for letter A. Well, A is at 6, 5. So, A is originally at 6, 5, and I want to cross the x-axis. So, my x value stays the same. My y value changes, so 6, -5. For letter B, it says graph the point C across the y-axis. C was originally 2, 1. Across the y-axis means my x changes, so I get negative 2, 1. For letter C, graph the point F across the x-axis and then state the coordinate point. So F is negative 3, negative 2 originally, and I'm going across the x-axis, so my x doesn't change, but my y does, it flips. For letter D, graph the point E. E is at negative 5, 0. Okay, and I'm going across the y-axis, so my y doesn't change, but my x does. So I get 5, 0. Letter E is graph the point B. B is 4, 6 originally, and I'm going across the x-axis, so my x doesn't change, but my y flips, becomes negative, so I get 4, negative 6. For letter F, I'm graphing H, which is 4, negative 4. Okay. Across the y-axis, so my y doesn't change, but my x does. For letter G, graph the point D. Well, D is originally negative 4, 3. Okay, and I'm graphing across the x, so my x doesn't change, but my y does. For letter H, graph the point G across the y-axis. G is 0, negative 4. And I'm going across the y-axis, so my y value doesn't change, but my x value does. Now it's 0, so they didn't move anywhere. So it's still going to be 0, negative 4. So I can't have a negative 0, it doesn't exist. Okay? Letter I, graph the point I, negative 2, 3, and then reflect the point across the x-axis. What is the new coordinate point? So I'm reflecting across the x-axis. So my x stays the same, my y changes. So I get negative 2, negative 3. So these are what your answers should be, and then I'll show you where the points go.
Door's locked.
All right, so this is what your graph should look like at the end. And that is the end of Chapter 1, Lesson 4.